Manfred is the founder of the German Quantum Alliance. He's, yes? Yeah, it's okay,
yes,
right?
Yes, yes,
yeah.
yes.
Member of the governance board of QuIC, the European Quantum Industry Consortium.
Yes.
And also on the board of the Bitkom working group.
Yes.
And I learned that for you, the key to success when it comes to quantum is the ecosystem of high-performance computing and quantum computing. And this is also why you started with the Deutsche Bahn getting into different engagements.
Yes.
So do you want to say one sentence before I leave you on stage, or am I already getting too much in your presentation?
No, thank you. Thank you very much. Thank you very much for having me. Thank you, Mira, for the introduction. And I think we met last time in Garching.
In München, by the Munich Circle.
Yes, yes. When we have seen how hybrid computer will be implemented, the hardware high computers will be implemented in the data center with the IQM system. And what I would like to share, it is difficult to hear myself. Can you sound it up somewhat?
Yeah, I also have trouble, but they hear us. I always ask and see it thumbs up.
Yeah,
so
they do. So I don't...
You have to cope with it.
Okay.
You have to cope.
Okay. So what I would like to introduce you is the journey we did at Deutsche Bahn regarding quantum computing. You asked these guys over here, how do we start? Mm-hmm. And now I can show you how we started 4 years ago now with this quantum stuff, when it was some of these hype topics with a lot of PowerPoint, with a lot of ideas. But we were waiting for the systems, and the journey we did in Deutsche Bahn, I would like to introduce you to you and show you what we did and where we are from an industrial perspective.
Beautiful. Yeah? Then quantum technologies in rail. Manfred Rieck, let's give him an applause again.
Thank you, Mira.
Have fun.
So hopefully most of you arrived today with the train. Daniel, great. Great, great. And I hope most of the trains had been in time. Some of the trains which were not in time will be in time when we have implemented all this stuff. So our vision within Deutsche Bahn is to make the organization, this large enterprise, quantum ready. This doesn't mean only that we optimize what we have, our assets, our rails, our trains, our people, our energy, but on the other hand, it means that we have to consider the security aspect as well. And this is what I will show you, what we do within Deutsche Bahn. So the quantum part is only one part of this ecosystem of AI and IoT and data lake and not anymore blockchain, I suppose, but it's power, energy, it's computer power we need to get this kind of digital twin realized in the future. And for us, it's a kind of coprocessor we need, and a coprocessor we will use when we are able to use them and when the systems are big enough. So we have seen currently they are too small, so we are only able to work with some toy problems, but these toy problems are relevant for us to understand where we can use them and which use cases we can solve with it. So we started with this from a strategic perspective, 2020. There we had a digital strategy implemented, and there was quantum computing, HPC and quantum computing already considered. And this was the starting point for my activities as well, when I started with these nice Planck guys and from Anacor now with the first project. So we are part of this ecosystem of Planck, and we are happy to be one of the 19th organizations working on the services we are now able to offer you on the Planck platform. So I myself, I started founding a team within the organization, although it's difficult on one hand to find adequate people, and on the other hand to convince your CFO, what the hell do you want to do with quantum computing? And one of the central questions of our CFO is, where's the business case? How can I calculate it? When do I have the efforts from this stuff? And how do you want to pay for this? And this we call it Q team. This Q team is a small group within the enterprise, which is responsible to investigate how far these quantum systems are. How are we able to implement on these systems? It's not PowerPoint, this is very relevant for us, but it's relevant for us that they implement on these systems, on the available systems. And on the other hand, to secure the organization, because we have a white side of the moon and we have a dark side of the moon when these systems are available, and we are aware of both of it. So on the one hand, we have the opportunities. As I mentioned at the beginning, we are planning to optimize the routes of our trains, the usage of our rails, the usage and the routes of our people, of our staff, and of our energy, of the whole stack across the network we have in place. It's the traveling salesman problem for the computer scientists, and it's one of the complex problems we haven't solved so far. And this was a starting point on the positive side. On the negative side, we are aware that there is a threat in place when these systems are available. So our security, our asynchronous security is endangered, and so we need to be prepared for this. So I built up two groups. One group is working on the optimization stuff, and the other group is looking on the security stuff to investigate how can we implement the algorithms which are quantum secure when they are available. So as I mentioned, it's difficult to get some money from your CFO. So for us, it was one way to get some research money from government for this. So we are involved in several research projects like PlanQ, like the Enigma project, where we deal with hybrid algorithms. And this was enabled us to get some, I think 40% of the money from the government, and the rest is risk money from our organizations. And as mentioned in the group at the beginning, there are hundreds of use cases. I think thousands of use cases we can use, and therefore we focused on two. On one hand, circularization optimization of our trains. This is one of the standard traveling salesman problems which need to be solved. And the other one is the DB cargo part, it's the single wagon scheduling, a problem which isn't be solved and which is a huge problem for our DB cargo organization. So just to show you some of the use cases we implemented in PlanQ, and some of them are from us, the capacity and circularization optimization, for example. This is an overview where we see what PlanQ did so far. And this is not only, as I said, it's not only PowerPoint, but these are use cases which show how these systems can be used. It doesn't show the advantage yet, but it shows how to implement a kind of QUBO and how your software developers have to think when they transform from the classical software development approach into this quantum approach. So it's completely different of thinking. It's not only the tools, it's another approach. And this is what you can find within the PlanQ, at the PlanQ platform. And here, the services, most of them are usable for you and can be implemented in your current application. So the circularization optimization for Deutsche Bahn, you see we have around about 250 trains. I think now it's around about 300. We add every month 2 or 3 of them. And no, 330, we have 350 now. And we have 250 stations, these large stations, and they need to be interconnected. And this problem can't be solved right now on a real optimum. It's solved on an approach, on an operations research approach, which doesn't deliver the optimum, which is sufficient today, but which wouldn't be sufficient in the future when we add additional trains on the rails and when we got more assets in our system to double our passenger numbers. And this needs to be mentioned. So at the moment, we don't need really real-time data. So when the data has some latency of some seconds or some minutes, this is not difficult for the whole system because it's not a high-speed system at the moment. But when we got additional assets into the system, then it can't be calculated anymore with the solutions we have at the moment. Then we need other solutions. And at the moment, we are working with the hyperscalers, with AWS and Azure, with Microsoft. And there we buy some computer power. And we can scale via computer power, but this is not, it's not tricky. It's not, I think it's not so intelligent. We're looking for more intelligent solutions, and therefore the approach to investigate what these quantum computers are able to do for us. So the first use case has been implemented in the first step on an annealer, on a Fujitsu annealer, then afterwards on a D-wave annealer. Then we became aware, yes, I agree. Then we became aware that the D-wave is still too small, so we have gone on to a simulator. And now you see some numbers. Do we have it here? We needed around, for 5 stations, 100 trains and only 200 journeys. We need around about 200,000 qubits on a D-wave. And the current has 5,000 or something like this. So this is already a toy problem. So just think what we need when we try to solve real problems, real world problems. But it's for learning what we can do with this system. Therefore, it's more than enough. And to investigate how we have to change the skills within our organization. We have around about 4,000 developers, and some of them need to do this in the future. So to investigate what we need to do there, this is more than enough for us. And the other use case we have is the single wagon scheduling, which means we optimize the single wagons of our DB cargos. And this is more, at the moment, it's more a theoretical approach because the trains are long-lasting 700-meter trains, and it's not so far implemented that we can that we have an answer how complex the system, the hardware needs to be to solve this problem. As I mentioned before, we are involved in the research program PlanQ. And the second program we started by August last year is the so-called Enigma. Enigma means it's a combination of classical approach and quantum-based approach. So you divide your algorithm or your problem into a classical approach where you solve it with operations research methods, as we do it since 30 years now. And one part of the problem could be solved probably with a quantum-based approach, and this, therefore, we need this hybrid this hybrid solution, and this is what we are working on at the moment. So we are looking on from a software perspective what we need, instead of most of the guys here around looking for the hardware, which hardware they can offer to us. So for us, it will be the next step, not having only one large quantum computer, but we suppose we will have hybrid systems, an HPC system, and this in combination with the quantum system as they implement at the moment in Garching with the IQM, and I think which is planned in Jülich as well with the D-Wave and the, what is it, the French one? Masala. Yes, with Pascal, yes. So just for you to consider, it's could be a step in between before the large systems are available. But on the other hand, I suppose this could be a solution for us to make them usable, earlier usable for us. This is the positive side I mentioned. So this means large computers are available. We have the software stack, we have the hardware, we have some platforms, we have all the services, and all our optimization and material science will be done on a quantum system. But on the other hand, we know that these systems are dangerous. And we know that these systems will break in the future when they are available, when they are large enough. They will break our encryption, at least the asynchronous encryption like the PKI systems. And therefore, we build up a second group which investigates what does it mean? What does it mean when these systems are available? BSI is calculating with 2030. When these systems are available, how do we have prepare ourselves? How do we have prepare our systems outside, the critical systems we have in place? And last but not least, the harvest now, decrypt later problem. So your data are stored today. And when these systems are available, they can be broken, and everybody knows what technical or what commercial data your organization has. So in the US, they reacted with a kind of memorandum. So mid of last year, there was a memorandum from Joe Biden to prepare the government and the industries towards this. And by end of the year, he came up with a so-called Quantum Preparedness Act, which is much stronger, which means that they had 90 days time to have a master plan how they plan to prepare themselves against this attacks or these possible attacks. And when you're in the US, for example, or when you're in the UK, you see the guys running around, and they are very somewhat nervous because they know they have to do something. They're not such relaxed like here, yeah. But what we assume is this needs to be mentioned when we work with this quantum stuff, the positive side and the dark side of the moon as well. So the BSI in Germany came up with this document by, I think, the second edition by end of last year. And this is not, let's say, it's not complicated what's in there. It's not, you don't need to be a crypto expert. You don't need to be a quantum expert. It just says that you need to have to know where crypto is in your organization implemented right now. So you need a kind of inventory, which many organizations doesn't have, large organizations. I think every startup has it in place. And on the other hand, when you've got this inventory, you need to be able to prioritize your applications and figure out when and how you are able to prepare them to become a kind of crypto agile, which means in Germany, the BSI says you add another crypto quantum secure algorithms towards your application. It's like you are helped here, and you have good belt and everything. And this needs to be done for every application, for every critical application, to be secured against attacks, which will be there in some years. At the moment, we say these are only recommendations. When you look across the ocean, when you look into the US, and when you look to Europe, to other countries as well, you see there comes some more drive into this topic, and we expect that this will become more or less a regulation within the next year instead of only recommendation. And the preparation of an organization to get it crypto agile takes at least, for large enterprises, 10 years, 12 years, 13 years. And I'm not sure whether these large systems are not in place within the next 5 years. And then you are, for 5 years, unsecured. All your data, all your financial data, all your private data, and all our governmental data as well. So this is just the information for you to get back to your CIO and CISO in the organization to make him aware there happens something. It's not only fun to have a quantum system in place and to use it for optimization, but on the other hand, it is necessary to prepare this and to be aware where to get the money to get this prepared, because it's not for free. So this means for us, in addition, this needs to be done in a systematical way. It means that let's say, the vendors you've worked with in the past, you need to figure out, are they still the vendors you plan and you will work with in the future? The IT architects talk about a zero trust strategy. All this needs to be considered when these systems will raise up and when these systems will be available. So for us, as Mira said at the beginning, for us, the ecosystem we are in is very important. So therefore, we are engaged in several ecosystems across the world right now. And what we see from the, when you look for the several dimensions of these ecosystems and where we need help is from a governmental perspective, the co-financing. This is what we do at the moment, and this is, let's say, this is what you can take with you when you talk with your CFO, how to get this paid. There is co-financing money in place, yeah. And we need the industry, because the industry delivers use cases. I think the universities doesn't have the use cases at the moment, and the research organizations as well. So therefore, we are closely engaged with the research organizations. And last but not least, and this is very important when we look into the future, this quantum stuff doesn't go away. So, and we have today already, we have not enough staff, not enough people working with this and like to work with this, because it's a kind of risk to jump in this topic. The universities will produce people in the future, but on the other hand, the industry needs to produce, let's say, experts as well, not only PhDs, but what we need are quantum developers. We need people who are able to transport the business case into a quantum use case. So this is what we are missing at the moment. We don't have enough quantum consultants. We are looking pure on technology and pure on implementation, hardware and software, but the consulting part is currently far away, and this is very difficult to transport this topic into your board of directors, into your senior management heads, because they are still smiling when you are talking about quantum. So, as I said, in Germany, we want to double our passenger numbers, so we need other approaches. We can't make it as we did in the past via computer power from data centers. We are involved in the QuIC organization. QuIC is the pendant to the Japanese part, the Q-Star, and the US QEDC. So it's the European Industry Consortium of around about 190 members across Europe now, including the UK and Switzerland, I have to say every time. And there we exchange all the information, what happens in quantum computing across Europe. Not to stop on the border, because what you see at the moment, what happens in Switzerland, it's fabulous. And what happens in France as well. So we need to be aware of what happens all across Europe. And we are involved in this German Industrial Association for Quantum Security, where organizations come together and figure out, without looking for the, let's say, for the paycheck, how do we prepare our systems, and who are the players in the field, and how do we work, for example, with the NIST organization as a European player. And last but not least, I founded this Federal Quantum Alliance, where I can show you, wait a second, where I can show you what we do together with the Bundesdruckerei in Berlin and the Deutsche Rentenversicherung. The idea is to get our experts, our crypto experts together. Every company has a handful of them, not more than 2 or 3 or 5, to get them together and to get an exchange, an information exchange established between experts. Because what we expect is that especially governmental organizations will have quantum experts in the next future. They go to the industry. And therefore we established this. We had one of the meetings some weeks ago, and they came together and discussed about the last NIST algorithm, which has been implemented on a very, very high level. And this is my recommendation as well. go into these ecosystems, in these groups, and try to figure out what the others are doing and exchange information. So the recommendation at last is we need a risk-taking attitude. So this is what Anacor is an example for. So this guy started without knowing whether they will have success or not, or the other startups as well. It's a risk and an opportunity. So on one hand, we have the opportunity that we will improve our systems. On the other hand, it's a risk because the option that the quantum advantage will never be shown is there. Yeah, we must be clear that it's there. And what is important to convince your senior management, your top management, is don't talk quantum or talk technology, but make them aware which problem do you want to solve for them. And whether it will be done with a quantum system or an HPC system or a combination of both, this is irrelevant for them. They need to have a use case which solves a problem, a business problem they have. And then they are happy to spend some money, especially when you get additional money from government to this. And as I said, establish not only technical experts, but also business experts in the organization, because the translation of a business problem into the quantum world is difficult. And when a quantum or when a business expert says, I will improve the search time in your database with a quantum computer, then you know this is the wrong business expert. Then you have to start the education again. And it's a marathon. This won't be done within the next 1 or 2 years. It's a marathon, and I think we need some additional breath for this. Thank you. Are there any questions?
Yes, thank you very much for this interesting talk. Always nice to see that big companies are seeing the potential for quantum technologies and the optimization. So I have a bit of a concern, and that is that there's a very wide consensus, especially in the optimization community, that qubits are not the way to go.
Yep.
And I mean, you saw it yourself that you need 200,000 qubits for even small problem sizes. And like state-of-the-art TSP solvers, they can solve millions of cities. And with the Kubo implementation that scales with the square and the qubits, you literally need trillions. That is like a 1 with 30 or 12 zeros, so it's completely unrealistic. So my concern is that you're building up all this infrastructure for solving problems which are based on qubos, while it's not really realistic that this will ever be a viable approach. So yeah, maybe you can comment on that.
Yes, the approach, solving it with Kubo, was one of the first approaches we started 3 years ago. And when you say we are building infrastructure, we have people in place and we are involved in research projects. And research means you go in one direction. Sometimes you figure out it's the wrong direction, then you go for another direction. So I think the investment from our side is very small, and it's part of the game that you are going to the wrong direction and then have to change your approaches you have. And therefore this ecosystem is very relevant for us, because there we are in close exchange with the research organizations, with the universities, because enterprises, small or large enterprises, are no quantum organizations. We are not a quantum startup. So therefore this ecosystem, this is the investment which we are taking. Yeah, and I think this is, it's not so much that we are not willing to do it within the next years as well. Maybe there comes a completely new approach in place we are not aware yet. Yeah. But what's important for us is to be prepared. not to see when you look for this generative AI stuff. It was let's say, an approach which is not completely new, but the whole industry, or more or less the whole industry, was completely surprised that this topic or that this solution will blow up like this. And therefore, what we do is we prepare our organization on this quantum stuff with a small team, not with hundreds of developers, but with a small team to know where it is going. And when we are aware that this advantage will be shown or will be a reality, then we will grow the division. Yeah.
All right, thank you.
Welcome. Thank you. Can you speak up somewhat louder?
Hello? Ah,
yes. Oh,
yes.
yeah.
Thank you also from my side for the talk. What I'm interested in is actually the state of the art for the problems you're now trying to solve with quantum computers, with annealers and stuff. Is it already being mathematically optimized? Is it?
No.
No. Okay, so it's just. Yeah,
it's
person, I guess.
Yes, it is. It is person, and the idea is that we use let's say, a real world problem where we have some data. We've learned data is most important everywhere you're working. You need data for the AI stuff, for the quantum stuff, and so on. So you need a source for the data, and then our approach is to just start and figure out, not to go from start with a theoretical basis, but start implementing and using for example, the QuIC. Yeah?
Okay, but the problems that you want to optimize are already well defined in terms of just the mathematical model, in terms of the actual issue you have.
Yeah, this is what we did in the beginning. Therefore, we stick on this one optimization problem of trains. So this has been defined in the meantime, and what we try to avoid is to look for several problems and to start describing them again and again, as long as we don't have some results, some advantage results for the problem we have already defined. Yeah.
Okay, thank you.
You're welcome.
There are no more questions. I think, Manfred, you did a good job.
Thank
Let's give
you
him
very much.
another applause. Come on.